Welcome to this limits lesson. In today's limit lesson, we're going to learn about factoring limits. Now, what do I mean by this? Well, limit problems are not terribly hard to solve, if you ask me. But we can always make them simpler, and that's always a good thing to be able to do. You probably learned what factoring was in Algebra 1, maybe Algebra 2. So, say we have a problem like x squared plus 6x plus 9 is equal to 0. We can simplify this problem and make it much easier to solve by factoring it. In this case, our factors are x plus 3 and x plus 3 are equal to 0. Now that we have our factors, we can set each individual factor to 0. So x plus 3 is equal to 0 and x plus 3 is equal to 0. And of course, to solve this problem, we would just subtract 3 from this side, so then x is equal to negative 3. We can use the fact that we can split this up and factor it in order to make solving some limit problems a little bit easier. Let's do a couple examples to show you what I mean. Our first example will be x squared minus x minus 6 divided by x minus 3. What is the limit of this problem as x approaches 2? What is that equal to? Now, at first glance, this is a lot of math that we just don't really want to do. But we can make this a lot simpler really quickly. You may notice that in the numerator of this function, we have a function that looks a lot like the form ax squared plus bx plus c. And if we have a function in this form, in other words, we have a squared factor, just the variable, and then a constant, we can factor it. So let's do the factorization of this problem. X squared minus x minus 6 equals 0. So my question to you, what are two numbers that add together to equal negative 1 and multiply to equal negative 6? That will give us our factors and make this problem much simpler. I'll give you a hint, you already know one of the factors because of how this problem is set up. Think you've thought of that factor? Well, one of our factors is just going to be this bottom function. The idea with factoring for limits is that we can cancel something out. And in this case, with division, we're probably going to want to cancel out whatever is on bottom. So we know that one of our factors is x minus 3. So what would our other factor be? What other number, along with negative 3, could be used to add up to equal negative 1 and multiply to be negative 6? If you said positive 2, you are correct. Just to double check this, x times x is x squared. I say x times x is x squared. X times 2 is 2x. Negative 3 times x is minus 3x. And negative 3 times 2 is negative 6. Add these two together, we get x squared minus x minus 6, which is the same as we started with. So we can replace our numerator, which was this x squared minus x minus 6, with our new factored function. This will turn into the limit as x approaches 2 of x minus 3 times x plus 2 divided by x minus 3. Now here's the cool part. You may notice that we have an x minus 3 and an x minus 3, one on top and one on bottom, which means we can cancel that out. And this makes our problem so much easier. This turns our problem into the limit as x approaches 2 of x plus 2. And this is much simpler to solve. All we have to do is plug in 2 as x is approaching 2. We just have to plug in whatever x is approaching to our limit function to solve for our limit, which is equal to 2 plus 2, which of course is equal to 4. So the limit as x approaches 2 of x squared minus x minus 6 divided by x minus 3 is equal to 4. Let's do two more examples just to get the idea down. Let's do the example of, our next example will be the limit as x approaches 1 of x squared minus 2x minus 15 divided by x minus 5. What is the limit of this problem? Let's find out. Let's use the green marker just for funsies, why not? May as well get some different colors up in here, right? Once again, we have a factor up here in the form of ax squared plus bx plus c, which means that this is factorable into x and x. Like that, like we just did in the last example. Meaning that we can turn this into two factors that multiply by each other to equal this and possibly simplify our problem down. Let's try this out and see if we get our factors simplified. Okay, so let's factor x squared minus 2x minus 15 is equal to 0. I'm going to ask you the same question I did last time. What two factors can add up to be negative 2 and multiply to be negative 15? One way to think of this is whenever we want to multiply to equal negative 15, we could find some factors of negative 15. So some of the obvious ones would be 1 times 15 equals 15. But what are the other two common factors of 15? That's right, 3 and 5. But you may also notice that this 15 is negative, so one of these two also has to be negative. So it could be either 1, it could be negative 1, it could be negative 5. We'll just use that as the example here. Now this one is piquing my interest. 3 times negative 5. That does equal negative 15. If we add negative 5 to 3, we get negative 2, which means that 3 and negative 5 are our factors. So x plus 3 and x minus 5 equals 0. And just to make sure, we have x times x, which is x squared. We have x times negative 5, which is minus 5x. We have x times 3, which is plus 3x. And we have 3 times negative 5, which equals negative 15. Adding these two together, we get x squared minus 2x minus 15 equals 0, which is the same as what we started with. So let's change it into our factors. We have the limit as x approaches 1 of our two factors. So x plus 3 and x minus 5, all divided by x minus 5. And just like last time, you may notice that we have an x minus 5 on bottom and an x minus 5 on top, which means these two cancel out. So now we simply have the problem, the limit as x approaches 1 of x plus 3. Once again, we can simply just plug in whatever x is approaching for x, in this case 1. So this will equal 1 plus 3, which is equal to 4. And that is the limit as x approaches 1 of x squared minus 2x minus 15 divided by x minus 5. Let's do one more example for today's video. In this example, I want to highlight that you don't have to have your function in the form of ax squared plus bx plus c to utilize the factoring rule. Let's do an example now where we don't have to use that. Let's say we have something like x squared plus 3x divided by x. And we have to find that function limit as x approaches 2. What can we do to make this problem a little bit simpler? Well, we can factor the top. You may notice that the top has an x in both parts of it. So we can change this limit problem into the limit as x approaches 2 of x times x plus 3, and then divide that by x. And once again, you may notice that we have an x on top, or an x on top and an x on bottom. And once again, we can cancel those two out, which means this problem is actually just equal to the limit as x approaches 2 of x plus 3. Once again, to solve limit problems, we just have to plug in whatever x is approaching. So we can plug in 2 for x. So this is just equal to 2 plus 3, which is equal to 5. And 5 is the limit as x approaches 2 of x squared plus 3x divided by x. I hope this video helped you out. If you want more calculus lessons, check out my playlist, and if you want to move on to other ways to solve limits, click this video up here where I'll show you how we can use rationalizing to solve limits. I'll see you guys in the next video.